So first of all, I want to remind you guys that there was a Delta Math assignment assigned the first Thursday of school, first day of school. So it's due this Thursday. We have tutoring this week as long as we are in the building. Miss Howard will have tutoring on Monday, and Miss Kennedy will have tutoring on Tuesday afternoon. Wednesday will be Miss Dim and Miss Reiner in the afternoon. So we have a quiz on Thursday. That'll be our first quiz of the semester. And there is no school next Monday, okay? So here's our warm-up. Go ahead and pause the video. Go ahead and do this warm-up and then come back to me, okay, guys? All right, so let's go ahead and work through this. So remember, if we have parentheses, we're always going to do those first. So when we work this problem, we're going to do x to the 2 minus 5. And then we're going to do that to the third power. So this is going to be x to the negative 3, and then we're going to multiply that by 3. So this is going to be x to the negative 9. So if we write that without the radical, it's going to be 1 over x to the 9th, okay? Which would be b. All right, now number 2, we're going to go ahead and simplify this one. So we're going to do the numerator and then we're going to do the denominator. So we're going to do 2 to the 3 minus 2. And then in the denominator, we're going to do 2 to the 5 plus 1, okay? Remember, there's a 1 right there, okay? So this is going to be 2 to the 1st over 2 to the 6th. Now we're going to bring it all up. So it's going to be 2 to the 1 minus 6. So that's going to be 2 to the negative 5. Now remember, if it's negative, it goes to the denominator, right? So the answer is going to be 1 over 2 to the 5th, which is C, okay? All right, now let's go on to today's lesson. So in today's lesson, M7 1.1, we're going to talk about radical expressions and rational exponents, okay? So we're going to kind of switch back and forth between a radical symbol and a rational exponent, okay? So first I want to talk to you all about the number of real roots, okay? So when we have a nth root, and it's even. In other words, when we're talking about roots, we're talking about this letter up here. See how this n is up here, y'all? So if it's an even number that's there, then when x is less than 0, it's no real root. Why? Because if we take the square root of a negative number, we get an imaginary number if we get a number at all, but there's never going to be a real one. When a is equal to 0, it's going to be 1 real root. And when a is greater than 0, it's going to be 2. Why? Because we put the plus or minus in front of it, if you remember, when it's an even root, okay? So now when n is an odd root, if it's less than 0, we get 1 root. If a is equal to 0, we get 1 root. And if a is greater than 0, we get 1 root, okay? So no matter what, with an odd root, we get 1 root, okay? So now let's talk about what these things are so you guys know our vocab, okay? So when we have x to the a over b, that is going to be represented when we put it in a radical is where our a up here, notice our a up here, is going to be our exponent, okay? And our b right here is going to be our index, okay? Now what we call this symbol that looks like this symbol right here, y'all. This symbol is what we call the radical. And then the term underneath the radical is what we call the radicand, right? So this term right here is what we call the radicand, okay? Just so you guys know what the terminology is. So we've got an exponent, and so that means our numerator is going to become our exponent always, and our denominator is going to be our index. So I always try to keep people to remember the index is what? What is the index, y'all? It's the denominator, right? And then that means our numerator is our exponent, okay? So this is going to be our numerator, okay? That's what you need to keep in mind as we start moving through this lesson. Very important. Okay, so this says given the radical form, write in exponential form. Given the exponential form, write in radical form. Okay, so the very first thing we're going to do here is we're going to change a to a radical. Okay, so we're going to put our 4 under there because that's our radicand, right? And then we're going to put our index as our denominator. Our denominator is our index, right? So the 4 goes right there, and our numerator is our exponent. Y'all see that? So what I remember is the index is the denominator, because then I know that the numerator is the exponent, okay? So here again, let's go ahead and simplify this first. So this is going to be equal to 9 to the 6 over 1 times 1 over 5, right? So that's going to be 9 to the 6 over 5, right? Now we're going to write it in radical form. So we're going to put our radicand under there at the 9. And remember, our index is our denominator, so we got our 5 right there. And then we've got our 6 right there, okay? So over here with the -8, again, we're going to put it in our radical. That's going to be a -8 there. And our index is our denominator again, so that means that this is right there. The 3 goes as our index, okay? So now with b, same thing. Square root, we're going to put b as our radicand. And this time it's a -1/4. So do you guys remember that that means that I go 1 up here, right? So that means that our whatever our value is, it goes to our denominator, right? And then remember here too, this is going to be our index. Our index is our denominator, so that's going to be the 4th root of b. All right, so the next one is we're going to actually transform this one now into a rational expression. Okay, so we're going to put it in exponential form basically. So we got our a, and remember our index is our denominator, so our 5 goes there and our 2 goes on top, okay? And with f, this time again, we're going to write this is f to the what? 1 over 6. And then this down here is f to the 5 over 1 times 1 over 6, yes? Okay. So that means we've got our f to the 1/6 in the top and our f to the what? 5/6 in the bottom. So now we're going to combine these. So this is going to be f to the 1/6 minus 5/6. So this is going to be f to the what? -4/6, which can be reduced, right? So we're going to go ahead and do that. So that's going to be f to the -2/3. Okay. So now we're going to actually put that in radical form. So it's going to be 1 over, our f is our radicand, right? So we're going to put our f there. And we're going to take our 3, and it's going to be our index, right? And then our 2 is going to be our power. So that's our answer right there, okay? All right, so now I'd like you guys to try these and then come back to me when you're done, okay? We'll do one at a time. So let's go ahead and do G, pause me, and come back to me. We're going to write that one as a radical, right? Okay, so now we're going to put our C underneath our radical. We're putting our 8 there and our 3 there. Remember, index denominator, okay? The next, so once again on the next one, we're going to put that -6 as our radicand, and then we're going to put the denominator as the what? The index. So that 4 is going to go right there. Okay, so on the next one, go ahead and pause me again, go ahead and do it and come back to me when you're done. So on this one, we are going to put it in fraction form. So we're going to say G, and remember, the index is the denominator, so my 3 goes there, my power goes my numerator, right? So my exponent is my numerator. Okay, now J, pause me here, go ahead and do J and come back to me when you're done. So on this one, we could write it as a radical, or we could write it as a fraction. So we're going to do both, okay? So here, I'm going to go ahead and do this first. This is going to be y to the 5 over 1 times 1/2. So that's going to be y to the 5 over 2, right? And that's times, we're going to go ahead and go y to the what? 7 over 2, right? So we want to do that first because we want to get them in the same form so that we can combine them, okay? Then what we're going to do is we're going to add our exponents, right? So 5 plus 7 is 12. So it's going to be y to the 12 over 2, right? So what's that going to be? That's actually going to be y to the 6th. So that is what this is in simplest form. So we don't have to put it back in radical form, do we? because the radical was eliminated. So then this says when f is greater than 0 and d is a positive integer, because obviously it can't be 0, because if it was, we can't divide by 0. When f to the negative 4 over d is equal to which of the following expressions? So let's go ahead and just write this, okay? So we got our f here, right? And it's going to be negative, so it's going to be 1 over. Y'all see that? And then what is our index? Our index is going to be the d, because that's our denominator, right? And then we're going to take this 4 right here, and we're going to put it to the power. So which one looks like that, y'all? 1 over the d root of f to the 4. So that's d, isn't it, y'all? Okay, let's look at the second one here. It says, use the expression to answer the following question. 8 to the third over 8 to the negative 1/4. Okay, so which of the following answer choices is the simplest form of the given expression? So what I like to do when we're doing these, we want to give this a common denominator in the numerator. So I'm going to show you guys how to do that. So this can be 8 to the third. Now it's going to be 3 over 1, right? So we're going to multiply that by 4 over 4. Because that's still 1, right? So this is going to be 8 to the what? 12 over 4. Hopefully you know that 12 over 4 is 3, right? So now that's going to be over 8 to the negative 1/4. Now we can just work the problem, right? So this is equal to 8 12 over 4 minus minus 1/4. Now remember, I'm subtracting that 1/4 because it was in the denominator, but it was a negative, so I'm subtracting a negative. So we're going to make this positive, because remember, a minus is a positive. So that's going to be 12 plus 1, which is going to be, so this is going to be 8 to the 13 over 4. So now we want to go ahead and put this in radical form, right? So we're going to take our base, and that's going to be our radicand, and we're going to take our denominator, and it's going to be our index, and then we're going to take our numerator right here, and it's going to be our what? Power. Yep. So which one of those looks like that? The 4th root of 8 to the 13th. So that's our B. Okay?